This is Mark Anderson from Kellogg Community College. I will be going through the third part of our three-part series to look at the review for the Chapter 1 and Chapter 2 test. These are selected problems that might help focus your studying for the first test of Math 121 Intermediate Algebra. Okay, so we're looking at a story problem here of population. In 2002, the Michigan city of Augusta was 950 people, and in 2009, it grew to 1,014 people. So let the P of t represent population in 2 years after 2002. Now, we're going to find an equation from this, and I'll first of all show you how to find it by hand, and second of all, I'll show you how to find it on the calculator. So the first thing we're going to need when we need an equation is we need a slope. So the slope equation is going to be y minus y over x minus x. And in doing that, what I'm going to do is take my y minus y, our years. So this is going, or sorry, not my years, my population sizes, because we have 2 points here. We have the point at 2002 and 950. We also have the point at 2009 and 1014. So there's my x and my y. So I'm going to go 1014 minus 950 divided by 2002, or 2009, excuse me, divided minus 2002. Now, an alternative set of points that you could use here, which might actually help you with the calculator work, is 0, 950, and 7, 1014. Because this is really going to be, t is going to be the years after 2002, so 0 is going to be our 950, and 7 is going to be our 1014. The slope is going to be exactly the same. Our numerator would be 64, and our denominator would be 7, because whether I use 2009 and 2002, or 0 and 7, there's still a difference of 7 years between our two x values. Now, what this is going to give me a slope of approximately 9.14, and we'll round to 2 decimal places. So what this gives me is the equation P of t that starts at 9.14 for my slope for every year. So we're gaining about 9 people a year in Augusta. But the question becomes then, what's my y-intercept? And it's really handy if I use this as my start time, because this is going to be the first year that I took the data. So it's going to be starting at 950. We are going to be going up 9.14 people every year. Now, if you stuck to these points here, what you'd have to do is find the y-intercept for the beginning of time. That means in year 0, which doesn't really do us any good. So this is our equation right there, and I will show you how to do this on the graphing calculator. Now, to find the part B, where it says use the function in part A to predict the population in 2012, what we will do is take that equation and think to ourselves, okay, how far was 2012 away from 2002? And doing just a little simple mental subtraction, you'd get an answer of 10 years. So all I'd have to do is plug 10 into my value of t right there. So this is going to be P of 10 instead of P of t. And we're going to go 9.14 times 10 plus 950. So it's going to be about 91.4 people, because that's what 9.1 times 10 is, 91.4, plus 950. So your answer is approximately, since this is an average, or an approximation, 1014.4 people. Now, if you were to do this on the calculator, and this is going to be kind of important to do for the extra credit, we're going to go to our calculator here, and we're going to go turn it on and get to a clear screen. Click on the Stat button, and then click Enter. Now this gets us to places where we can enter our data. We're going to type in 0 and 7, because that was the year, that was the distance from 2002, and that's the distance from 2009. And then over here, we're going to go to 1,000. Sorry, not 1,000. We're going to go 950, and we're going to go 1,014. And that gives us, this is our, this will help us get us our formula. Now the shortcut is going to be to click Stat, then Write, then 4, and for the newer calculators you'll have to scroll down to Calculate and hit Enter, but here I just hit Enter, and not only do I get my equation, the 9.14, which was what we had up here, it gives me my start, which is 950. And then to find out what it's going to be in 10 years, what you can do is one of two things. You can type in your 9.14 times 10 plus your 950. You can do that to get your answer for 10 years into the future. Or you could go to your calculator here. This is a skill we'll be actually using in our later sections. You can type in your 914x plus your 950. Now, hitting the graph won't do anything since this will be off the screen because the y-intercept is 950, but you can go to your table, second graph, and you can scroll down to 10 and see that's where it was in that amount of time. So that's kind of a handy little trick there. Okay, so let's go and take a look at some other problems here. We're going to look at section 2.5 right now with problems 27 and problem 28. So hold on a second here. Let me scroll some stuff down. Okay, sorry about that. A little bit of a screen adjustment there. Okay, so now it says write the equation. Let's see. It says write the equation of a line in point slope form, containing the specified point and parallel to the indicated line. Now, instead of doing just point slope form, what I'm going to do is use point intercept form. So I'm going to change this to y equals mx plus b. And because this is what I mostly prepared during the this is what I mostly did during the work. Now, if you want to choose to put your answer in point slope form, that's fine, but for the purpose of this review, I'm going to use the slope intercept form. Alright, so we have to go through this point and through this line. Now, what the first thing I'm going to do is I'm going to fix this so I can find my slope. So I'm going to move my 2x over here. And in moving my 2x over here, I'm going to have negative 3y is equal to negative 2x plus 5. Then what I'm going to do is I'm going to divide everything by negative 3 to get my slope that I need. Alright, now since negative 3 is a monomial, I can divide each of these by that monomial. So y is equal to, this is going to be a positive 2/3 x, and this is going to be a negative 5/3. So now I know the slope that I have to look in reference to. So this is my first line, and I need a line parallel to that that will go through this point. So I have the point negative 4, negative 5, and now I'm going to use the slope 2/3. And why would I use the slope of 2/3? And the reason why I would use the slope of 2/3 is because I want the line parallel to it. I want the line parallel to it, so here's what I'm going to do. Step 1, write down my y equals mx plus b. Step 2, I'm going to plug in my points. This is going to be negative 5. This is going to be 2/3, positive 2/3. This is going to be negative 4, and this is going to be plus b, because I need to find my y-intercept there. So what I'm going to do is then take my 2/3 and multiply it by negative 4. If I can do this on the calculator, it'll give me negative 8/3. 2 times negative 4 is negative 8. 3 times 1 is 3. That's to explain it there. Then I'm going to add 8/3 to both sides. And using the calculator function, I'm going to add negative 5 plus 8/3. And so when I get done here, my b is going to be equal to negative 7/3. And I'll show this to you on the calculator about how to do that in just a moment. But what this will give you is your b value. So your new answer is going to be y equals 2/3 x minus 7/3. So our parallel line has the same slope and a different y-intercept. So this is our answer to problem number 27. In problem number 28, it's the same question. You'll notice that I've cut and pasted the problems, but instead of saying parallel, I said perpendicular. So when I fix this equation, it's going to work out to be this y equals 2/3 x minus 5/3. See, since it's the same equation from up above, when I fix it, it's going to give me the slope. But now I'm going to go through the point negative 4, negative 5. But instead of my slope being the same, because they were parallel, since they're perpendicular, the slope is going to have to be negative 3/2. So the problem changes because instead of using the same slope, I'm going to use the opposite reciprocal slope. So this means my equation, step 1, y equals mx plus b. Step 2, substitute. I'm going to substitute my negative 5 in for the y, my negative 3/2 in for the m, my negative 4 in for the x, plus b. Step 3 is to simplify. Negative 5 is equal to, if I multiply these together, I get a whole number which is 6, plus b. Subtract the 6 from both sides. b is equal to negative 11. So my answer to this problem is y equals negative 3/2 x minus 11. So you can see that my answer to the problem, compared to the fixed equation up above, it is a perpendicular line because the slopes are opposite reciprocals of each other, and this y-intercept will go through this, will take this line through this point. Now, I said before moving on, I want to show you this little calculation here, negative 5 plus 8/3, how you do that on the calculator. And how you would do that is by just typing what you mean, but if you want to go negative 5 plus 8/3, make sure you put the 8/3 as 8 divided by 3 in parentheses, and this will give you a decimal. To convert that decimal into a fraction, you'd click the math button and then hit 1, and this will take whatever decimal you had before and turn it into a fraction. And there's how I got my negative 7/3. Obviously, a lot of that is easier if you can do that in your head. I think after a lot of practice, you will be getting to that point. But let's go take a look here at the last two problems on this side of the worksheet. All right, so what we have to do here is we have to do the following. We're going to subtract these two functions. So we're going to subtract f minus g of x. So we're going to take my f of x, which is our 2x minus 3, and we're going to subtract our x squared plus 4. Now, one of the common mistakes in subtracting the two functions of x is that a lot of us will just put a subtraction sign there and nothing else, when in fact you should actually have this in parentheses and these in parentheses, because these are two separate functions. The first set of parentheses were kind of superfluous, but the second set of parentheses are really important because you're going to be distributing that negative. So I got 2x minus 3 minus x minus x squared minus 4. So this becomes minus x squared minus 4. So then we can simplify this, and we have the only things we can put together are the negative 3 and negative 4. So 2x minus x squared minus 4, minus 7, because negative 3 minus 4, 7. But you can leave it like that, but generally speaking, when we write our answers, we'll have the highest power first. I will have some formal discussion of that. So our answer for the problem is either this or this right here. But we like to have our powers in descending order. That's just good math grammar. Now in this problem here, I want to show you two ways that you could solve it. We're going to take the same equations from up above and find out what will happen when we go f minus g at the value of negative 2. So what I'm going to do is take my f of negative 2 here. Alright, so I'm going to plug in negative 2 for this. Alright, and we got negative 4 minus 3, which is negative 7. And then what we'll do is we'll take our next equation, so my g of negative 2 there, and plug that in, negative 2 in for that. Be careful when you use, you got to use parentheses when typing this in. This will be positive 4 plus 4, and so what we have here is 8. So when we subtract these two numbers, negative 7 minus 8 is going to be an answer of negative 15. Now that's one of two ways you can do this. You can plug negative 2 in and then put them together. Another way, since if you have some confidence in that answer up there, what you can do is plug in a negative 2 in for the problem like this. There's 2 and negative 2 minus 7, and then compute it out. So this would be negative 4 minus 7, and the reason why the negative stays out in front and doesn't like swipe on the inside is because of order of operations. The negative 2 gets squared, which makes a positive 4, and then the negative comes out in front, so it really kind of looks like that. So negative 4 minus 7 is going to give you the same answer, negative 15. So whichever way you want to do it, I'd say that this method right here is probably a little safer in case you messed up on that algebra up there. Alright, moving to the last page here. Got a couple problems dealing with domain, and all we are having to do is find the domain here. So let's take a look first of all and see if there's any danger numbers in this first problem. There's a danger number here because x cannot be equal to 2. And x cannot be equal to 2 because if I plug 2 into the denominator, what happens is that, well, I get division of 0 error. Now this problem has no restrictions at all because you can plug any real number into x and you'll have no problems at all. Now what I'm going to show you here is if I'm adding these two functions together, I'm only going to have the one denominator problem. And I'm not going to actually simplify this, but I want to show you that if I'm adding them together, x can be anything that's real and x cannot be equal to 2. Because I'm not creating a new denominator by putting these next to each other. Same thing goes here for f times g. So if I put these two functions next to each other like so, I'm not creating a new denominator. We still have the one excluded value, so x is going to be real except x cannot be equal to 2. Alright, and the same thing goes, well, the same thing would go with subtraction, but now what we're moving into is division. And the division problem is going to be a little trickier because now what I'm going to be doing, if I'm actually visually looking at this problem, is I'm taking my first problem here, my x over x minus 2, and I'm going to be putting it over my 2x plus 3. Now, we still have my exclusion that I cannot have a 2 in this denominator here because that would give me division of 0 here in the top part of my problem. But now down here, I can't have a certain value for x. And to find that, I would have to set my denominator not equal to 0 and find that danger number. So I'm going to subtract 3 from both sides. So I got 2x is not equal to negative 3. Divide both sides by 2. X is not equal to negative 3 halves, or negative 1.5. So now what I have is a new exclusion, and my new exclusion here is that I can have all real numbers except I cannot have x equal to 2, and also I cannot have x equal to 3 halves, because that negative 3, or so the negative 3 halves, because if I put the negative 3 halves here, this is going to give me a negative 3, and that means I'm going to have negative 3 plus 3. I'm going to have 0 in the denominator here. Now the trickiest problem dealing with this is going down to problem this g divided by f, and I want to kind of scroll forward here a little bit so I can get some room to write. Alright, so what makes this tricky is that I'm going to be putting my 2x plus 3 in the numerator, and in my denominator I'm going to have x and then x minus 2. Now, of course, one of the problems if I put a 2 into this number here, I'm going to have x over 0 or 2 over 0, and that's going to give me division of 0 error. So you think to yourself, okay, great. So x is going to be real and x cannot be equal to 2. But in fact, I missed one on the answer key. I forgot that if I plug a 0 in for this x, this will give me 3 over 0 divided by negative 2, which is 3 over 0, and 3 over 0 is division of 0 error. So there is a second danger number right there that's easy to miss, but if this whole denominator here becomes a danger zone in that case. Now the last thing I'm going to do with you is show you how to do this problem here. And to do this on your calculator, and the reason why you want to do it on the calculator is because we're going to find an approximate slope using the linear regression model on your TI 8384. And you're going to need to do some fixing first. The first thing you want to do is change these to 0, 1, 2, 3, and 4, and 5. And what this is nice is that you're going to actually use these numbers right here to kind of help you get these problems down here, because you're not actually going to use a y-intercept that goes back to year 0. This is going to be your y-intercept. So instead of thinking of the year 1994, think of that as year 0, the start of your equation. And 1999 is year 5. That means 2000 is year 6, and 2010 would really be 16. and then 2015 would be 21. Now, what's important about that is that when I do these problems, I'm going to think of my answer as, in 16 years, what's my y going to be, or the population? In 21 years, what's my y going to be, or the population? So that means that my answers here are going to coincide with the equation on the calculator. So here's how you do it. You're going to prep your table like this, and when I go to my calculator, this is all going to go away, so hopefully you've done this on your paper. Alright, so now I'm going to my calculator here. So I'm going to type in my year and populations. So go to my stat. Now I have some numbers in here, so if I move up one click and hit clear enter, that all goes away, which is nice. Clear enter. And now I can type this in. I'm going to go 0, 1, 2, 3, 4, and 5. Instead of typing in the years, I'm typing in the numbers, 0 through 5. Now over here, I'm going to type in 260.30. Whoops, I'm sorry, I'm doing that in the wrong place. I'm going to go over to my list 2. There we go. And type in my data here, 260. It's a little faster if I use the numeric keypad here, so let me type that in. Making sure I don't make a mistake here. Alright, do a double check to make sure I didn't type any decimals in wrong. And I'll perform my shortcut, stat right 4. And for the newer calculators, you'll have to scroll down to calculate, or you can just hit enter. And that gives me my equation. My equation is going to be y equals this 5.37 plus 257.26. Now to find out what my answers are for the year 16, or 16 years later, and year 21, I'm going to take that equation and plug it into my y equals. So this is going to be 5.37x plus 257.26, and then I'm going to go to my table, second graph. And I'm going to scroll down to 16, and that tells me that my data was, my population is going to be about 343.18 people, or million people in this case. And at the 21st year from 1994, we're going to be at 370.03 million people. Alright, well that is how you would do that. To put this on the screen here, we're going to rock back to writing this down here. The equation is going to be y equals 5.37x plus 257.26. That means we're growing at 5 million people a year, starting with approximately 257.26 million people. Even though this right here was my start, the y-intercept was slightly adjusted because this is a kind of an average of the slopes that we have there. Alright, so this is going to be, in 2010, we'll have 343.18 million people. In 2015, we'll have 370.03 million people. Alright, well thank you for watching, and give me an email if you have any questions.